So good afternoon, everyone. Let me just start the presentation here. So good afternoon, everyone. Welcome to this series 4 of Archicad Now. So again, I have with me James Badcock, our BIM consultant. I'm Marcelo Morin, the business development. So today we bring you, I think, a topic that has been quite heavily required when on the feedback form. So the topic today will be how we can do interoperability through Open BIM. So I have some considerations and some information that I want to pass it to you today. Then we'll have on the next episode, a bit in line with this, how to use the Revit RFA and RVT geometry exchange so that we can access Revit families BIM library to bring that contact into Archicad. Then we'll show you Paramo and Python. So this is also a very strong point of Archicad 24. So how we can automate with the Python scripts and how we can create parametric objects that are generated with node-based programming. And on the 13th of August, we'll have the pleasure to have architect Ricardo Dias. He is in GVDC, which is Global Virtual Design and Construction in Hong Kong. They will bring us a construction case study, so how to use modular integrated construction. So I think it's similar to PPVC in Singapore. So how they use this case study in Hong Kong. This will be quite impressive. So I advise all of you to sign up for this session. So today's topic is improving interoperability through Open BIM. And I would like to highlight here that I will be using mostly or the base of the materials that is part of a GRAPHISOFT BIM class that is called Archicad Open BIM Collaboration. If you sign up for GRAPHISOFT Learn, if you have your GRAPHISOFT ID and your GRAPHISOFT ID is connected to your SSA, you'll be able to log in, go inside this GRAPHISOFT Learn, and some of the trainings will be free, some will be a discounted rate, some of the materials as well. There are some documents that you can download from there, so that you can have access to this premium content. You can also click on this or scan this QR code to access the page for GRAPHISOFT Learn. In the meantime, James has also put on the chat the link for this page. Thank you, James. So to start this topic, we need to understand first what is Open BIM. Right? So basically, the Open BIM concept is a universal approach to design and collaborate based on open standards and workflows. So basically, the keywords here is one is open standards. So these are standards that every vendor can comply with, and workflows that have to be followed. So it doesn't mean that they are cast in stone. You can always like figure out things that are not working exactly, and then you can dig in and see what's not going perfectly, and then you optimize the workflow. But workflow means that between multiple users, we need to make sure that we figure out how we're going to work together. So this is an initiative that includes many software vendors. So GRAPHISOFT is one of them, and Building Smart is the one that oversees and creates all this movement. So basically, Open BIM, one very important concept I want you to have is that it's bigger than IFC. So IFC is a file format. I will explain a bit later. But Open BIM is more than that. It's actually like any file format exchange you need to have so that you work together, that should work for you. You know, sometimes we want to send information, it's better or more comprehensive to send it in Excel or a TXT file or an XML file or in DWG or in PDF. So we'll see in different type of information that would make sense for us to send it in different file formats. Okay, so I mentioned Building Smart just now. So Building Smart is the developer of this IFC file format. So it's a truly open format that every vendor should be able to comply with. Then they also have this model view definition. This pretty much um, dictates how the information should be translated into IFC, and then from IFC, it's almost like a dictionary of how the information goes from or flows from one software to the other. Then we have BCF. BCF is a format for collaboration between multiple platforms. So let's say you're in software A and you send the information to software B, but you want to send a message with certain elements attached to that to the other software. So BCF is the file format that allows you to do this. If your BIM tool doesn't handle the BCF directly internally, Archicad does it. If it doesn't do, there might be add-ons that allow you to do that, or even some standalone platforms that allow you to do this BCF collaboration. Very important also under Building Smart, there are many different chapters and participants. So Singapore is one of them. Malaysia is also there. And there are many national BIM standards. So this sometimes makes difficult to work between different BIM standards, but there's more and more talks or progress into centralize the BIM standards. So for example, in Europe, they're trying to come out with an European BIM standard. But this will keep changing. What is important for you to know is that in Singapore and in Malaysia, this is already being taken care of. Okay, very important concept for this talk is that when we transfer information about a project, there's not only one single type of information. So one is geometry. So we want to know the shape of the elements, the exact representation that they have. Then we might want to know properties, so like all the things that we tag the element with. For example, if this element is it going to be a slab or a roof or a wall or a column? Normally, these are built-in information on the elements. And then we have the documentation that we produce, the 2D documentation. Basically, we can transfer this information in different ways. So the geometry and the properties, they will go through the IFC file format. By the way, for those who don't know, this is the symbol for IFC file format. And if you want to exchange 2D documentation, IFC is not the way to do it, because IFC is to bring the geometry and the properties across. It's for model-based coordination. It's not for 2D documentation based. So the whole industry is moving from 2D documentation and all the manual process of representing a separate view from another and all this. So if you want to do this transferring of information into the of 2D documentation, you just export the views that you have from your BIM model in DWG and in PDF or the layouts, and then you can transfer that. So optimally, if you want to give a package with a model and the documentation, you should give them IFC or multiple IFCs and DWG and PDF file, or multiple DWGs and multiple PDF files. So to make sure that this works across different softwares, basically IFC file format and all the standards of working should assure this. But to make it even more improved. For example, we have developed as Graphisoft an add-in for Revit that it's called IFC Model Exchange. So if you install this add-in inside Revit, what this will do is that it will make Revit understand better the translation between an Archicad element into a Revit element through the IFC. So it's almost like a dedicated dictionary, you know, so that you know the what specific element, if it's properly classified or properly modeled, you will go through to the other software in that way. And this add-in is both used for import and export. So if, for example, you want to collaborate between Revit and Archicad, this add-in, it's definitely a must. So if you want to know in which page this is, you can just scan this QR code here or go to Graphisoft website and look for interoperability downloads, and you will find this there.
I just posted the link to the chat.
Okay, perfect. Thanks, Jim. So another thing that is important, as I mentioned, there are workflows that we need to follow. So as you can see here, so this Asia BIM is a blog that we are maintaining here in Singapore and Malaysia from Graphisoft team. And this is an article that it's been quite widely referenced. So congratulations to Chidam, is the one who figure out and properly documented how the coordination between Archicad and Revit for a project-based files. So let's say you have two disciplines using these two platforms. How do we coordinate the project origin so that when we reference each other's models from one to the other, they will exactly land on the exact location. Last thing we want to see is the architecture in one place and the structure or the MEP in a different location. So this article here will explain you how this project base file is set up between Archicad and Revit. So this is just an example of workflows that we need to go through and need to figure out the understanding so that this works smoothly. So in today's session, I will start by going through this kind of chart. This is a complex topic, so since we have about an hour for this session, I won't be able to go through all this. We can later revisit this topic and go more into details and cover the rest of the steps. So today, basically, we'll talk about the model preparation. So what are the concerns we should have in terms of model preparation so that when we want to export the BIM model to other disciplines, this goes smoothly. So basically, point number one and point number two will be the main focus. And I will also talk about import BIM models from other disciplines. So to go through the whole project life cycle, we need to know how to prepare the model properly. Then this doesn't need to be, you know, an extra layer on top of what we're working, but we can't just model things anyhow and expect the software to make sure that every element is properly classified and so that it's properly transferred from one software to another. Then we need to also have a few considerations when we export the BIM model for other disciplines. I will cover what are the things we need to focus here. So for example, model quality control, model filtering, using layers, filter and cut elements in 3D, partial structural display. So there are many things here that we should take into consideration. When we import, we should also do some proper mapping of materials, of classification, so that the elements go through properly. When we federate elements, we also need to know what is the correct process. Should we open directly an IFC? Should we put it on a blank file and then just link it into ours? So there are many ways that we can do this. We need to know how to check for the model and do a proper coordination, this is all inside Archicad, and we can obviously use external tools like Solibri Office to check this in a more automated way. And whenever we need to solve issues in our BIM model, so let's say there's a clash or there's a mismatch between two different disciplines, we have an issue, we have to go back, send a BCF, and probably go back to export the model with the new changes, then link it back to the other file until we make sure that there are less clashes in our project, less clashes or any other issues. So sometimes it's not just a clash that it's an issue. Okay, so based on this, I will jump into Archicad here. So so we can go through these topics inside Archicad. So basically, the project that we'll be using today is a part of one building at Graphisoft Park in Hungary. This is actually our HQ building, and you can see it here. This is not the total building, but just a part of it. But I think it's good enough to see because it has many different types of elements. It has structural elements. It's properly classified in some areas. In some areas, it's not on purpose, so that we can see how we can classify this. And it's bigger than a normal house, but it's also not like a skyscraper, so that we can very easily control and go through all this. But you can take the learnings that you have here and use this on any other project. Being an airport or a skyscraper it's basically pretty much the same workflow. Okay, so now we'll focus on model preparation. So for model preparation, we need to have a few things that we need to take into consideration even before we start the project. So we should have a BIM kickoff meeting, and in this BIM kickoff meeting, we're going to decide between the different stakeholders that will take part in the project what will be for example, the origin of the project and the north of the project. So for the origin of the project, we can use, for example, an object that is the project base point or a survey point. So if you use any of these, you can just set the coordinates, and this would be easier for you when you want to move the whole project. Let's say instead of moving the geometry all in one go, you just move one point, and then all the other coordinates about the project will be updated according to that change. Another thing, for example, that is important to take into consideration is the north. So if we go through the project preferences, we have here the project location, and you can see here that we can set the north either by keying in the angle that this north will have, or by define this on our floor plan view. We can also set here with the northing and easting the project location. So this is all referenced on the article that I mentioned before, how we should set these parameters. One important thing is that I forgot to mention that here is that some softwares take this north, so pointing up, as 0. Archicad takes this as 90 degrees. So this is important. If you're using one software that interprets this in one way and Archicad interprets this in another way, we need to take this into consideration when we're exporting the files, because this is one of the settings that will go on the IFC file. Okay, another thing important, as it mentions here, is the story setup. So the story setup is pretty much the levels that we have in our project. So we should define between the different disciplines, we should have roughly the same story structure, or at least, you know, if level 3 or story 3 in architecture should match, let's say, level 5 in MEP, because there's some intermediate levels, we should take that into consideration and make sure that, you know, with the heights and all this, we make sure that these structures, they match. Another thing that is very important is element classification. So as I mentioned earlier, this is almost like having a dictionary and knowing that, you know, in software A, when we translate to another one, will become an element will become something on the other software. So we have to make sure that the element classification is properly set, so that the elements, when they flow from one software to the other, they find their correct classification on the other end. Structural function is also quite important. So let's say if I want to filter elements by their structural function, if I'm sending my architecture to the engineer, I might want to turn off all the finishes and elements that are non-structural, so that they will receive that and work based on that. So they will know, if me as an architect put in some columns as design intent, they will know that they could work somewhere around there, and then probably they would make the columns bigger or smaller, or even with a different profile, so that the building has a better structural behavior. In terms of position, it's also important for other, for example, for analysis, you want to do thermal analysis of your model. Positioning, so knowing if an element is an internal or external, an internal or external wall, a window as well, they will know that they are exposed to the environment, and therefore they would have a different behavior. Okay, so next thing that is important, as I mentioned, is the classification. So basically, the classification is what matters, it's not the tool. So Archicad gives you, you can see from this complex graphic here, gives you the ability to use one tool, and that one tool be classified as another type of element. So for example, I can make furniture out of walls, or let's say a table, that I have a tabletop with a slab, I have the legs that are with a, you know, a slanted shape, and I use a column for that, and then I can select all those elements and classify the slab and the four legs that are done with columns. I can use classify them as a furniture element, so that when I send that externally to, let's say, a structural engineer, he doesn't consider the columns from a table as structural columns. So I'll give you an example here on how we can use this. So for example, this is a wall here. This wall is being classified, as you can see here, as a column. I can also classify it as load bearing or non-load bearing. I can set the position as internal or external. And as you can see here, this wall, in this case, being classified as a column, will go out as an IFC column. So whatever software opens this IFC will recognize this as a column. Okay, so we can make sure that we use the best tool that suits our modeling, but we have to make sure that it goes out with a correct classification, so that the structural engineer would know that this would be a load-bearing element and not just, you know, an ornamental feature there.
Yeah, and this classification is also important, even if you don't export it to IFC, but for creating schedules that are listed together and things like that as well.
Yep. Yeah, I will cover that
Okay.
soon. Yeah. So basically, this is what we need to take into account in our model preparation. So now we'll jump into the element classification. So again, this is still part of model preparation, but we're getting ready to export our model, right? So we know that this is going to go out, and we need to make sure that the classification is properly done. So one way that we can double check this is by using find and select. So we have this icon here on our screen that is called find and select. And if you use this, we can either choose criterias directly here. So you can see that I have created some specific criterias. For example, I want to find elements that are not classified. I want to look for all element types that the structural function is undefined. So by clicking plus this button here, I can see that, okay, I have these elements here that the structural function is not classified. So I can just choose to select these elements. So I show only the selection in 3D. And now I can go through each one of them and start defining if they're load bearing or not. So basically I have this slab here, and if I want to say that this slab is structural, I just go inside here and say, excuse me, mister, you are a load bearing element. So I make sure that it's properly classified. And then I can even put a classification here as a slab. So I know here that this is either I type here under the classifications, or I go through the whole hierarchy and I see that under the construction elements, I have this slab element and I put it here. So you see now this element, if I send it out to another tool, you will know when the other tool is importing this element, you will say, hey, you, what kind of element are you? You will say, hey, I am a slab and I am a load bearing element. And if you want to go even further, I can say, and I am an exterior element, because this is a balcony element, so is located outside. So you can see that with this, we can very easily double check the elements that are classified or not. So this find and select is a quite a strong tool. So if I want to, let me turn on all again, everything. So if I want to find elements that are non-load bearing, I just click here the plus, and you see that a lot of it is non-load bearing. But if I want to find only the load bearing elements, I just change it here. I click plus, and again, I can choose just to show these elements in 3D. And now I can see the elements that are classified as load bearings here. Just one remark here. If a wall is load bearing, what will happen is the window that is contained on this wall will also show. So I will show you later how we can filter this and turn off the windows in case we don't want to send this to the structural engineer. Let me put all back again. So this really helps us to understand how to properly classify the elements. Okay, next thing, another thing that we can use to verify this are the schedules. Actually, it's actually my preferred way. So you can see here that everything that it says that the position is undefined, I can see that this could be a problem. So it is not a problem if I don't care if the position is internal or external. So we can actually set here directly, if we know which wall is this one, we can set directly here the property, and this property will be fed into the native element. We can also change the ID of the element. So I can see here if, let's say, I have walls that are structural or non-structural, I can change the ID, for example. So I could do a schedule to verify, instead of the Archicad classification, I could verify um, if it's like a load-bearing element or not. I could look into it, and then I would add that property here to make sure that this element is being properly classified or not. So you see here, I'm looking at the Archicad classification besides the home story, the element ID, the position, and the layer. Okay, so now I want to find out the load-bearing elements. So you see here, if I do a find and select of these elements to see if they're load-bearing, they are not set. So if I have this pergola and I want to say that this is load-bearing element, I can just very easily classify it and change the classification. So change the structural function and change the classification here. Okay, so I could put like it's a construction element because it's one whole structural element that will come prefabricated and just assembled here on site. Okay, another thing that we can do is like filter elements by discipline. And here, for example, we could show everything on the architectural BIM model. On the structural, we have to do more things. So choose the load-bearing elements, choose the partial structural display to take out the finishes from the load-bearing elements, for example, and then we'll end up having a more simplified model. And we can also have, for example, the zones as a way to filter the model in case you want to send this just for analysis purpose. A zone contains a lot of information. So for example, if a zone is touching the windows or doors, or is touching any opening, you will know that that is an opening, and therefore for energy analysis, you will know how to go through this. So one more thing that we can do while we are testing if the file is properly done, we can also highlight using the graphic overrides. We can have a highlight of what are the structural elements in 3D. So if I open my graphic overrides, say I'm saying that whatever is structural in 3D, I want them to be highlighted. So in this case, the layers are not properly set, but we could imagine if this is coming from an external IFC that is placed inside Archicad, we just use the layers for that external IFC, and then we can highlight those elements in case they are structural here. So one way is to use this graphic overrides for this. Another way is the find and select, and a third way is using the schedules. If I want, for example, to filter this whole model now and prepare a view to send to a structural engineer, a few things that I can do or I should do for this is, for example, under the partial structural display, I want to turn off the finishes. So I define that I want to see this elements without the finishes, or even the core only of the elements, right? But this is showing the core of the elements that are structural and non-structural. So if I choose core of load-bearing elements only, in this case, it will filter out all the elements that are non-load-bearing, and it will make sure we get rid of it. Okay, so here it is. But we still have elements here that are not relevant for the translation between architecture and structural engineer, for example. So in this case, we should filter by using the filter and cut elements in 3D. So you go under view, elements in 3D view, and filter and cut elements in 3D. And here we can choose, for example, that we don't want to see the windows, doors, and skylights, and even objects. Or let's say we leave the objects because this might be classified as structural, which is the case of that pergola that I created there. So that if I choose it like this, then I see that my file is now reduced to only the structural elements. So when I'm sending the information to a third party, I'm sending to him only the relevant information. It's the same thing you would do with, when you're using CAD drawings. You would filter and just send the relevant information to the third party consultant. Okay, so once this is set exactly as you want, you can create one view. So you create a new view with the settings as we're seeing here. And we would give it a name. So for example, IFC for structure engineer. Okay, and then when we send this out, we will export properly the elements or only the elements that matter to us. Obviously, we have to make sure that they are properly classified, all of them. We can't just close our eyes and send this, because if all these elements are classified wrongly, they won't be going through exactly as they should be going. And also another thing I'd like to highlight here is that when you classify an element in a certain way, so you see I classify it as a wall, so this is a wall and it's classified as a wall. When it goes through, it brings this set of information that are called properties that can be used on the other side. So if I choose a different classification, instead of wall, let's say I put furniture, you see that now it has different set of information. So it has the manufacturer, production date, country of origin, and all that. So it's totally different to have different classifications when they go from one end to the other. Okay, so you see here now we have different ratings, concrete structures, space boundaries. So even the way how they connect to the zones is totally different. Okay, so we've gone through pretty much the first sorry, we've gone through pretty much the first part of our model. We have designed, we have modeled, and we have created the building exactly as it should be. We went through find and select, we went through schedules, we went through model view options to make sure that the elements have gone through from one end to the other. And now we are ready to export our model for other disciplines. So how can we export this? Okay, pretty much we need to be aware first that there are many different ways to export elements or not many, actually mostly two different ways, but then many small details inside each one of them. So the two main ways, one is the extruded or revolved geometry type. As the name mentions, extruded means that if it's a wall, the wall will have a construction line, so the direction which is extruded, then it will have a thickness and a height, right? And even if it's slanted, you will have a vector that will show that slanted vector. And even if it has like a complex profile, so a variable profile for the wall, you will be able to be carried away even with this parametric geometry. Another option that we have is the boundary representation. So this is called BREP. When we send a geometry as BREP, what it will do is it will lose the parametric capabilities of being extruded or being thickened. So it will be almost like a sculpture of that element in place. If you want to edit it, it will be more difficult, but at least you have the guarantee that this element is transferred perfectly. In projects, very often there are, I would say, most of it is possible to be sent as parametric geometry, so extruded. So in a way, it can be handled on the other end and can be changed on the other hand, if that's what you want to do. Even though IFC should be used mostly for model referencing, so we should link the geometry from the other end, and each discipline should be able to edit and change the model from their discipline. So what we do, the same way as we used to do with XREFs from other consultants, is we overlap with our drawings, in this case with our model, and whenever we see that we need to adjust our geometry or our building, we have to do that according to what comes from the other side. Either we do that or the other side will do that. So these are the two main ways to bring in the geometry. And for complex elements, for example, if we have a composite of a wall that is extruded and it has a composite and even has an airspace, so Archicad allows us to have this. We can actually export this as sub-layers and have this broken into multiple elements. Okay. So now I will jump to where we control this IFC translation. So pretty much after we have classified properly the elements, if we go here under interoperability, IFC, sorry, I have to be on a plan view. If we go to the IFC, we can see, first of all, we can go to the IFC project manager. And under this IFC project manager, we will check the hierarchy of the project. So how this whole thing was, the data is structured and being organized in this file in terms of IFC. So pretty much we can see from here what are the elements that we have. So let's say on the first floor we have all these slabs, and then we can see what are the properties that are going to pass through. So if we see them organized, we can see them organized by type here, or organized by assignment. So how these different elements are being assigned to different systems. So we can see one important thing to see on this is what are the kind of elements that we have here that will be exported. This should be like a really red flag for us. So whenever we don't know what to do about something, this will be going through as building element proxy. So you see that we have here curtain wall that is using a morph. So this element has got the ID of CW001, and then he has many sub elements that are frames and panels that are going to be transferred as separately as building element proxy. As much as we can, we should have the elements classified as their specific building elements. So I see here that this FU must be like furniture elements. So I'm okay with them being classified as being building elements proxies, but probably would be better to have them as furniture elements, for example. Then we can see the coverings we have here. We have curtain wall elements. We can see here many different curtain wall elements that are being classified and how they will end up on the other end. Okay, so this is something important that we should check before even exporting the file to the other third party. After this, another thing that we should check is the IFC translator. Okay, so the IFC translator allows us to set up a translator for both import and export. And as you can see, Archicad already comes from with default translators. For this was a file created in Archicad 23. That's why you see a lot of AC23. And I just opened it in Archicad 24. So basically here we can see the translator for import geometry from other softwares. So they already come predefined from our template. If you want to know, you want to set up something yourself, we can always take one existing duplicate, so create a new, and then we want to, let's say, duplicate an existing one. And then we can go through the settings of this. So first of all, we need to know what is the schema that we're going to use, if it's IFC 2x3 or IFC 4. So Archicad is already certified for IFC 4 schema, but mostly the industry is still using IFC 2x3. Then we have the model view definitions. So we have, this is, I don't know if you recall from the PowerPoint, it's one setting that this Building Smart defines. So if we want just to have the surface geometry, it will force everything out as BREP, or mostly elements in BREP. If you want to do for FM handover, you're mostly care about the information on the elements and not just the exact geometry and their proper classification. COBE 2.4 is also a standard that it's to comply with certain type of data structure. So let's say we want to do coordination view. So it's very important that we know what is the purpose of the data exchange. So if we're going to send something to a third party just to be open and reference is one thing. If they're going to open and edit some elements is another thing. So we need to be aware of this. Then we can name our a custom model view definition in case we want to create our own. We can also set here a description saying, for example, use this translator when exporting IFC structure model with consultant A, B, or C, you know. So we fine tune, we work so many times with this engineer or with this landscape or someone else, and we already fine tune what is the way that we transfer the data, so we can use this more often. Okay, so there's a few settings that we have in terms of conversion here. One is model filtering. So we have two options here. Either we filter the model in our 3D view, as I showed you before when I created that structural element, a structural IFC view, or we can come here inside and choose what are the elements that we want to send. We might want to filter by IFC domain. Let's say we don't want to send all the MEP elements or only the MEP elements. This will filter them and put them here. So I'll put all. I don't want to change this. Again, I would like to highlight, even though it says here select to the elements to export lines, text, labels, fields, doors and windows to the views, this doesn't mean that it will accurately be represented on the receiving end. So again, this IFC shouldn't be the way to bring in the 2D representation of the elements. Okay, then we can check the type mapping. Type mapping is, as I mentioned before, how the elements will be classified. So basically, if I go here under construction elements and I select a wall, this will go as IFC wall. But if I choose, so you see, if I choose any type of wall here, if I have a plumbing wall, it will have a predefined type. They're normally called PT, plumbing wall. So we can choose if it's a shear wall. So there are already some predefined types inside an IFC type, so that it can have an extra information that will go through in this IFC translation. Okay, so for example, same thing goes for a slab. So a slab can be classified, as a floor slab, as a roof, or and so on. So even though we're using this kind of elements, they could have a different way of being classified. Okay, so
yeah, and generally the template will have all of this, so you don't have to do it for every single project.
yeah,
So.
yeah. By default, I would say this is mostly set up already. So I don't want to, also bore you with too much information, but this is for you to understand. If we're not classifying the elements, the software is, and we close our eyes and send the information across. This is not like Google Translator that will try to find some words. You might have the geometry there, but the way how we translate it, the better it's translated, the better the message goes across. Okay, and the next thing I would like to highlight here is the geometry conversion. So what is this? The geometry conversion is what I mentioned to you before, that it can be extruded and revolved or be rep. Okay, so you can see that we have this few presets here. So if I want precise B-rep geometry, let's say I have a building that has super complex shapes and it's very hard for me to have this as extruded. So I will send everything as B-rep anyway. They just want to see the envelope of the building. I will choose here everything to be set as extruded or revolved as many times as possible. Another thing that is important is when we have elements that are intersecting themselves and they are subtracting some parts, they will create junctions inside Archicad. This is to assure, the cleaning up of the different building materials, to make sure that our drawings, if you have a section or a plan, all the different fields of or all the different layers of a wall will clean up nicely. So when we send this as extruded, we should make sure that the junctions, these very intricate junctions, are cleaned, so that when they go to the other side, they can be extruded. Otherwise, the other software wants to try to import it as extruded, and it fails to do that, and then we'll have a warning or an error saying, sorry, I couldn't make this wall extruded because there's too many junctions into it. so I don't know which direction I should extrude and so on. So this also brings me to another point I would like to tell you here, that probably you will have a project that everything will go through very smoothly extruded, but then you have an element, let's say in the roof or a canopy or a facade element that is super complex. And if those elements, you can send them as extruded, you will just prepare another view and export those elements in separately with a different kind of translator. And then on the receiving end, they would have to import all the extruded elements and then put on top all the BREP elements. So this is also, it doesn't mean that we translate everything just in words. Some things we translate with gestures or with a drawing. Is the same thing here. Sometimes we had to export 2 or 3 different parts of the model and then make them assembled so that we bring them in the best translation possible. Okay, so basically once we change this translator here, we can go through other details, but I pretty much covered the most important here. We can save this translator and then even pass it on to someone else. So we can export the translator here or import the translator so that this can be used for other projects or by other colleagues or even by other firms. So pretty much this is it that I had to showcase today. You let me know if you have questions. I'll be glad to answer them.
So far, nothing in the chat.
Is it?
So people can just open up their mics now if they have questions. It's quite heavy, maybe.
Yeah, I try to keep it simple. That's why I said from the beginning. I just want you to understand roughly the concepts today. What is the classification? What is type? What is a IFC property? How we translate elements? How we control if the model is properly classified or not? We can't just model everything and then go save as IFC and expect that the data will end up in the other end and being perfectly understood, right? We have to understand that these are different platforms and we need to make the platform's job as easy as possible.
Yeah, it's not like PDF and DWG, which is just a 2D representation. Like this includes all the model and data.
But even in DWG, that's a very good example. Even in DWG, there is translation. So, you can have a DWG that will have the lines by color or by type or by layer, So there are many, even in such a simple representation, which is like just flat 2D, you can have these problems. Or there's a font that is missing. The text is there, but then we need to go and get the font. So it's the same thing here. It's just that being geometry and having so many attributes and so many properties and so many classifications, we need to make sure that the things are properly done so that when they end up on the other end, they will be properly received. Anyway, if you want to find more about this topic, we'll revisit this for sure in next episodes. Probably we'll get our IFC expert here, Chidambaram, our BIM implementation director, to help us in these topics as well. And we'll also have this available on YouTube. So in case you want to revisit this topic, you can do it anytime. So any questions, or I scared off everyone from the chat?
Not in the chat, but anybody can open up their mic and ask questions.
So just to wrap up everything, you can follow us on social media. I've shown the LinkedIn, Facebook, and Instagram page as normal. We have this video will be shared on GRAPHISOFT SG in our YouTube page, together with all the other episodes. And if you go to our website, you can see the ongoing trainings we have happening in Singapore. Go to graphisoft.com/sg/courses. You can find this information. And we'd like to thank you and see you next week for the next episode of Archicad Now. I hope you all enjoyed. We answer your questions, and you can always refer back to this video. So thank you for your time.
Yeah, thanks.
See you next week then.
Thank you, guys.
Thank you, everyone. Thank you.
Thanks,
Hello,
Marcelo.
Josh. Thank you.
Stop recording.